Here we are in Chapter 5 review exercises, numbers 20 through 27, where it says factor the following. So we'll be breaking these up into binomials and or monomials that multiply up to this number. So we're unmultiplying. Here are the 5 methods we had. Greatest common factor, we always do this on every polynomial. The 4 terms, we do grouping. 3 terms with just a leading coefficient of 1, we just break it up like that. What times is to C adds to B. 4, we take A times C, and then we split B. That's the goal, and then we have 4 terms. We could do grouping again. If we only have 2 terms, we have the special cases here, difference of squares, or sum or difference of cubes. And with these formulas and patterns here. And then the last special case was actually a special case on number 4, that some of these turn out to be perfect squares. You check A and C being a perfect square, and then B being twice what A, B are together, and that's a perfect square. So let's do it. Number 20, first let's pull out a greatest common factor if we can. Is there anything that goes into 14, 10, 21, and 15? I don't think there is. This only has 2's and 5's, and that only has a 3 and a 7. So we now have 1, 2, 3, 4 terms. So we are right here with method 2. Chainsaw that puppy. And now take out of the first half, first binomial, we have a, looks like a 2. We can take out a 2a squared, and we're left with a 7a plus 5. What can we take out of the second one? It looks like a 3, and we're left with 7a plus a 5. How fortuitous. Grouping is going to work because 7a plus 5 is in both halves of it. So we can now take the 7a plus 5 out, and we're left with 2a squared plus a 3. Great. Next one, number 21. Is there a common denominator, a common factor with all of them? Nope, that only has x's and y's, and that doesn't have anything. So we go to 4 terms, 1, 2, 3, 4, we're in grouping. Chainsaw down the middle. What can we take out of the first half? A y. We're left with x minus 6. Here we can take out a 3, a positive 3, and we're left with x minus 6. Now there's an x minus 6 in both halves, and so we can take that out front, and we're left with this y plus the 3. We have unfoiled both of those 4 term polynomials. All right, number 22. Is there a greatest common factor? 2, 7, and 6? I don't think so. And how many terms? 1, 2, 3 terms. Leading coefficient is a 2, so we're down here in number 4. So we've got to take 2 times a negative 6 is a negative 12. Now what multiplies up to negative 12? We get a 1 and a 12, a 2 and a 6, or a 3 and a 4. Does anything add up to 7? Ooh, these guys do. But wait a second. We'd have to have a positive 3 and a positive 4. That does not add up to a negative 12, times to a negative 12. Is there any possibility of adding to a positive 7 times into a negative 12? No. So this guy is prime. He will not factor. You can try it for a long time and he won't factor. Even if you put a 3 and a 4 in there, it would not come out to work like this grouping up here does. So indeed, he does not work. All right, so he's prime. Number 23, 9m squared minus 121. First step, greatest common factor. No, this has just 3's and that has 11's in it. So we go down, there are 2 terms, so we're down here. These numbers, are they perfect squares or perfect cubes? And they appear to be perfect squares, 9 and 121. So it breaks up into 3m plus 11 and 3m minus 11. Excellent. That's what we needed right there. Yeah, when you multiply them out, this plus and this minus cancel the middle terms, and you'll be left with 9m squared minus 121. Excellent. Number 24. Do we have a greatest common factor? No. 1, 2, 3 terms, and the leading coefficient is a 1. So we look like we're right here with method 3. So this is just going to break up fast in one step. What times is to negative 24 and adds to a negative 10? We could have a 1 and a 24, a 2 and a 12, a 3 and an 8, or a 4 and a 6. Ooh, there are 2 options here. 4 and 6 sometimes add to 10, and 2 and 12 will subtract 10. We need to multiply, let me see, these guys would have to both be negative, but do those times to negative 24? They do not. Here you could have a negative 12 and a positive 2, and those times to negative 24 and add to negative 10, so those are the right ones. Plus 2 minus 12. Okay, that was good. Next one, number 25. Are there any common factors in here? It looks like there are a's in everything, so we can definitely take out an a. Oh, it looks like we can take out an a squared. We got an a squared everywhere. How many b's? B to the fourth is in everything, so we're left with a squared plus a minus 6. Okay, good. So we took that out. Great. Now what is left? We have a trinomial leading coefficient 1. So we are in number 3 right over here. So this is now what times is to a negative 6? We could have 1 and 6 or 2 and 3, and adds to a positive 1. Looks like if you take a positive 3 and a negative 2, that'll get it for you. So a minus 2, a plus 3, and this guy floats right out here. And so this is the complete factoring of number 25. Excellent. Now let's try number 26. Is there a common denominator? There is a common factor, not denominator, factor of an x, and we're left with 27x cubed minus 1. What's left has 2 terms, so we're down here in the specials. Is 27 a perfect square? No, we can tell here we have a cubed, so we're actually in this one right here. 27 is 3 times 3 times 3. So we're going to have to break it up with a cubed minus b cubed. So we'll follow this signs down here. So a is 3x and b is 1. That's what a and b are, because this is now a cubed minus b cubed. 1 is a perfect cube. So the rest is a squared, so 9x squared, plus, notice we're here on the bottom with this plus sign, through a times b, so that's 3x, and then plus 1. And we could try to factor this down more, but it turns out that this guy does not factor in general. So we are now done. Good. Oops. All right, number 27. Let's do number 27. X to the fourth minus 81t to the fourth. No common factors to take out, so we're going to be 2 terms. Are we at perfect squares or perfect cubes? Those are perfect squares. This would be x squared plus 9t squared, x squared minus 9t squared. Did these go down? Nope, this is a sum of squares now, but this is still a difference of squares. So this can go x minus 3t, x plus 3t, like that. Yes, indeed. And this guy just floats out in the front because he can't go down any further, but that one did. So it's kind of like this guy went like that, and then that guy went like that, and so the end result is all 3 of those multiplying together. Oh, good. That's 20 through 27.